Hello, what is up guys? Welcome to part 2 of our straight line depreciation method video. And today we are going to go over calculating annual depreciation expense and going over a problem to do with straight line depreciation. Also, we're not going over annual depreciation expense. That's what we went over in the last video. Today we are going to go over straight line depreciation rate. So anyways, over here you can see that one small difference which I have made is I have written a label over here, annual depreciation expense, because in the previous video, for some reason, I chose to write this as ADP instead of ADE. So just wanted to emphasize that it stands for annual depreciation expense. Now back to the video. So first we're going to go over calculating straight line depreciation rate. So I'll just use an abbreviation again, SDR. Just so I know these abbreviations, I don't think that they're commonly used. I'm just using them so that we can focus more on the math and this method on these methods than on the terminology. So straight line depreciation rate equals our annual depreciation expense. And what this measures, by the way, which again we've called ADP, but we really should call ADE. What this measures is it measures the rate at which the value of the asset depreciates, very similarly to what it's called. So that's the annual depreciation expense divided by the cost of the asset minus the salvage value. Again, this is pretty simple, right? Why this happens and how this works. So anyways, ADP is 20. So we have 20 divided by our cost minus our salvage we have over here as 80. So we can just write 80. And then this is equal to 0.25, which is equal to 25%, right? Depreciates at a rate of 25% per year. So now we're going to go over a problem. Company A purchases a machine for $100,000 with an estimated salvage value of $20,000 and a useful life of 5 years. Find the annual depreciation expense and the straight line depreciation rate. Okay, so I'm going to solve this problem by first drawing the graph, but normally if you're taking an FBLA business calculations test, you would want to get straight to just applying the formulas. I don't like saying that, and I don't like it when kids do that, but for these tests, they do go very quickly and you have to. So starts off at 100K. It depreciates all the way. It has a salvage value of 20,000, so it'll go all the way down to 20K. So let's do that. And this happens over the course of 5 years. 5 years. So let me just try to draw a line as straight as I can make it. That's pretty straight. And now let me just draw 1, 2, 3, 4. And now to calculate the annual depreciation expense, which I will now use ADE to describe instead of ADP. So this is equal to, let me just refer back to the formula just so that we can get a good look at it again. It's our cost. So again, this costs 100,000. So let me just use 100, then convert back to thousands, minus the salvage value, which again, we're converting back thousands, so minus 20, over our 5-year useful life. And again, this is really just how we would calculate the slope of this line. That's really all that this is calculating. And so anyways, this equals 80 over 5, which equals to 16. Yes, 16, right? 5 times 8 is 40 times 2, yeah. So this is 16, and now we have to remember that we converted, so we have to convert back to thousands, so 16,000. So every year, this goes down. This is going down by 16,000 per year. It's depreciating by 16,000. Now to calculate the straight line depreciation rate, I'll color code it. You know what? Just for you guys, I will color code it. Straight line depreciation rate. So SDR, again, I just want us to look at the formula again, is equal to our ADP, which is again annual depreciation expense divided by the cost minus the salvage value. So this is equal to our ADP, which we've described as ADE over here. So it's equal to 16,000. So again, let me just use 16, then convert back, over our cost minus our salvage value, which is equal to 80, as we have over there. So this is 16 over 80, and this is equal to, this should be equal to 16 over 80. So just thinking about this in my head, 0.2.